Hey guys, how's it going? And welcome to the Shrewsbury Biscuit Podcast. I would normally say I'm your host, Alex Whiteley, but I'm not really going to talk too much on this one. I'll leave it in the hands of the good professor. So on Saturday, I attended a lecture at the Unitarian Church called Climate Change, Evolution, Deniers and Anti-Science, and that was by Professor Jeffrey LEVERMORE, and it was a really great event. I mean, I don't usually go to things like this, but I wanted to go to support the festival, and because as well I find it interesting. You know, climate change is a big thing at the moment. You've got lots of things going on in America, which Jeffrey does talk about. Lots of people that don't believe that climate change, greenhouse gases, and all of this is legitimate, but it really is. And Jeffrey will talk you through that. I spoke to Jeffrey after the lecture, and I asked his permission if I could just share the lecture so people could listen to it. People might be really interested. The Unitarian Church could only fit so many people in, and I guess more people might want to listen to it. What I took from that event was as I looked around the room, and I could see people of all ages. There was a young lad behind me, could have only been in his early teens, that was enjoying the lecture. So it goes to show that everything that's going on with this Darwin Festival at the moment is for everyone, and this was a great example of that. I get there's going to be some parts of this lecture where he's pointing to slides that are visual, so it might not be as brilliant as if you were there or as if it was on a video, but I don't have TED Talk kind of money, so I'm bringing you just the audio on this show. I hope you enjoy it. I mean, if you listen to it and you learn something, then, if two people learn something like this, I win, and Professor Levermore wins. So I hope you enjoy it, and I'm going to leave it at that, and I hope you are enjoying your week, the start of your week. And I appreciate not everybody's got time to sit and listen to a podcast, but you know what? If you're doing like geography or something in school, or you're learning about this thing anyway, or you're generally interested, you might enjoy it. Put it on while you're doing the housework or something. But anyway, I'll leave you to it. Take it away, good professor. Thanks, guys. Peace out.
I'd like to introduce Professor Jeffrey LEVERMORE to you. He's Emeritus, is that how you pronounce it? Professor at Manchester University. Obviously his specialism is climate change and the built environment, because that's what he's going to talk about. He's worked for the IPCC, and I had to look that up as well, Intergovernmental Panel on Climate Change. And along with Al Gore, he shared a Nobel Prize, was it in 2007?
Yeah, with 800 other people.
Well, 800 other people, so a tiny piece of Nobel Prize, £2.50's worth or something. And at the moment, I believe he's analysing climate change and the urban heat island and building energy use. I'm sure he'll explain what that is to you if you ask. Thank you very much, ladies and gentlemen.
Can you all hear me? Yeah. Good. Thank you very much for inviting me here. I do come here and preach now and again, and towards the end I'll say a little bit about ethics. And I will mention a bit about evolution, although I'd stress that I'm not a biologist, I'm a physicist, and I'll be talking mainly about climate change and buildings, and also the facts and climate deniers. What I'm going to do is climate change to start off with, and then the built environment, renewables and new technology, not quite as much on that, unexpected consequences, climate and evolution deniers, they seem to go together, and anti-science and the importance of science. Sorry, I'm probably standing in the way. And a little bit at the end on ethics and morality, and then finally conclusions. And we have questions at the end. If there are any burning questions or somebody thinks I've said something wrong and controversial, please shout out. Right, so climate change, just to talk a little bit about this. We've got the greenhouse effect. There's the solar constant, which is pretty constant depending. It varies a little bit by about 10 watts per metre squared. This is the solar irradiance that hits the Earth's atmosphere from the sun, and it is remarkably constant, and irrespective of sunspots and so forth. So when we look at this, you see on the left there, the world consumption is much less than the total solar insolation, the amount of solar radiation, by a considerable amount. And the first thing you think is, well, we could use solar a lot more, which is indeed perfectly true. But a lot of that goes into the atmosphere, and it's generating wind, clouds and so forth, that the whole of our existence depends on the sun. And if I go theologically, it's no surprise that our early ancestors were actually sun worshippers, because without the sun we are dead. And all our fossil fuels come from the sun effectively, which has been the plant growth, the tree growth has actually formed all our carboniferous fuels. And we can actually use it directly as well. And if we look at it, the steady state balance here, the amount of radiation coming in equals the amount of radiation going out. So we've got the 235 on the left there, here, and the amount going out is exactly equal to what's coming in. So it's steady state. This doesn't mean to say it's going to stay like that forever, because we actually are contributing more carbon dioxide. So this is just an elementary picture of what's happening. And it's the fact that the short wavelength radiation from the sun can get through the atmosphere, but the long wavelength radiation, when it hits the Earth warms up, and it gives that long wavelength radiation, which is absorbed by the atmosphere, particularly by carbon dioxide, and also water vapour. So water vapour is also a very good greenhouse gas, but the fact is that it only stays up there for a certain time, and most of it seems to come and fall on Manchester. But it's a regular cycle, whereas the carbon in the carbon dioxide we're putting into the atmosphere at the moment can stay up there for hundreds of years. So what we're actually doing now is affecting generations for hundreds of years to come. Whereas the water vapour that goes up there comes down fairly quickly. And it's just like a greenhouse, that the glass will let short wavelength radiation in, but it will not let the long wavelength radiation out. And this is why greenhouses get fairly hot. So this is the greenhouse effect here, and it's circular there, whereas it's absorbed into the atmosphere. Some of it escapes and some of it comes back down again. And it gives us an average temperature on the Earth of about 14 degrees C. And the greenhouse gas effect is good, because if we didn't have this gas here and we just had the radiation escaping, the temperature would be about minus 14 to minus 20, and it would be a snowball. So our life here depends on greenhouse gases. It's just that we don't want too much of them. And we can see that the carbon dioxide is increasing from this graph, and the red line goes up and down because most of the greenhouse gases come from the northern hemisphere, where we've got the majority of land and we've got the seasons of summer and winter. And during the summer and spring, the carbon dioxide is absorbed as the vegetation grows, and in the winter it doesn't. So we've got that zigzag line, but the general trend is up. And we've now gone beyond the 400 limit. There's 380, but it's gone beyond there. This stops at 210, and it's regularly marching up there. And this is what climate change looks like, looking at various projections using computer simulations, which I'll talk a little bit about later on. And these are effectively, these representative concentration pathways are what we call scenarios to see what will happen in the future. And a lot of people would criticise these, but all intelligent people look to the future, to what's going to happen. It's difficult to predict, but we've got to try and do it. And there are different scenarios, because we are not talking about climate change being as a result of X degrees C higher than it is in, say, 1990. We're talking about a range of temperatures. And there are different scenarios, which I'll discuss a little later. Now, when we talk about climate change, we talk about this carbon dioxide as effectively a global warming forcing, and of about 0.6 watts per metre squared. Now, this is from a TED talk by James Hansen. And James Hansen is quite a well-known scientist, and he's also been in trouble with the authorities, and he's been arrested a few times as well. And he equated this 0.6 watts per metre squared to about 400,000 Hiroshima bombs a day going off. This is the effect of 0.6 watts per metre squared. Now remember that 0.6, because it's important. We all know what happened with Hiroshima before and after. But these are the representative concentration pathways that are being used at present. And just note that here we're talking about 2 watts per metre squared, which is almost 4 times the value that we were talking about with Hansen. So you can multiply your 400,000 Hiroshima bombs by 4. This is what's going into the atmosphere. This is effectively the heating up of the atmosphere. And it's just that we've got such a large planet that this is going into the air and it's going into the water. And there are 4 scenarios, and we can see that there's the bad scenario, which represents 8.5, down to the black one, and then the red one, and then the green one. So there are different scenarios that you can look at to see what the projections are going to be. And all of those scenarios are equally unlikely. A strange thing to say, but they are all equally unlikely. So they're not exact predictions. And the grey areas are plus and minus. With all experimental data, you have a certain amount of experimental error. So we're not being exactly precise in what's happening, but we're looking at trends. And the heating is quite important, that here we've got the land and the ice and the atmosphere, and here we've got the amount that's going into the ocean, 700 to 2,000 metres, and then we've got the amount of heating that's going into the ocean between 0 and 700 metres. A few years ago, the air temperature over land was levelling off, and a lot of people said, oh, well, climate change, you all predicted it was going up, and it's not. But the thing is, water has one of the greatest retentions of heat we know in most materials. And a lot of it's going into the oceans, and the oceans are expanding. And 2/3 of the Earth's surface has got water on it. So this is the greater heat content. And if we stop putting carbon dioxide into the atmosphere as of now, the oceans will keep on expanding. And again, it's many, many years they carry on expanding for. So that's more important to a certain extent than the measurements of the land. And there are quite a few measurements now in the sea and the oceans to monitor this. Now this, I got these slides from Robert Mulvaney from the British Antarctic Survey when he gave a lecture in Manchester at the Lytton Film Society there. And it's the work they're doing in Antarctica. And notice that they're actually drilling ice cores because the snow that falls in the Antarctic just stays there until more snow comes and falls on it, until more snow comes and falls on that. And the end result is you get a layer building up of snow which then turns to ice. But the great thing from the scientific point of view is that you've still got little pockets of air that are trapped within the snowflakes and around them. So when you actually drill down and get these ice cores, which can go down kilometres, you can actually analyse those little samples and find pockets of air, and chemists can do wonderful things on that and work out what the atmosphere was many, many hundreds of years ago. And if we, this is one of the samples that he actually handed round a sample like this, and you put it up to your ear and you can actually hear it cracking, because as the air in there expands it starts cracking the ice. And you're actually listening to air that's been trapped there for hundreds of thousands of years. And they can then analyse that. And once it's analysed, you can look at some of the chemicals there. Now, if you remember nothing from this lecture apart from this one slide, this is very, very important, because there are isotopes of carbon. Now, carbon traditionally has a nucleus with 12 nucleons, protons and neutrons. But you get isotopes where you can get an extra neutron added on. It makes no difference electrically and chemically to that carbon. We all know about carbon-14, which is for radioactivity. And that's how you date things, because it's got a long life, but it's radioactive and decays. Carbon-13 is stable, but it's also got a nucleus that is slightly bigger than carbon-12. Now, I'm getting onto slightly thin ice here, and I'm looking around. There are some very good biologists around. That the interesting thing is that photosynthesis has actually evolved. And in the old ancient times, a lot of the trees and vegetation was what they call C3. Little carbon-3 is the basis of the photosynthesis. And then about 8 to 15 million years ago, there was an evolution. And it was quite a change that you get C4 photosynthesis, which is more efficient and can deal with lesser amounts of carbon dioxide in the atmosphere. So that is after the Carboniferous age. And that means that when fossil fuel is burnt, you would expect a certain amount of the C3 carbon coming out, whereas when it's part of the natural cycle, it will be more C4. Why is this important? Because C4, I think, can absorb the isotope carbon-13 more than the C3. So we can differentiate between whether that carbon dioxide comes from carbon, which was the ancient C3 route, or whether it's more the C4. Now, C3 and C4 are still mixed up, but the various proportions, and we're talking about a very small amount of carbon that is carbon-13, but chemists can do wonderful things, and they can find very, very small trace elements of these. And so you can look at the change in the atmosphere of the amount of carbon-13 isotope that's there. And this actually starts to, it goes along fairly steadily, and then it starts falling off down there. Now this is a logarithmic scale, and I won't explain this, but you can see that there's a change. And that change is probably about 1750. and it starts to go down. Why? Because we have the Industrial Revolution and people were burning a lot of coal. Coal was one of the main drivers for generating steam for the Industrial Revolution. So we can see what we are putting into the atmosphere. And this is what Mulvaney rightly calls the smoking gun. This carbon-13 isotope. So this is what we are doing to the atmosphere. And a number of people now call that the Anthropocene, which means it's the geological era or time that mankind is actually affecting it. And you can actually see that influence of mankind on the actual planet in the gases like this. And the result is that, carbon dioxide is going up like that. So this is a smoking gun. We can actually see and date the start of our affecting the atmosphere. And it's steadily getting more and more, and the result is the carbon dioxide is going up there. And the beauty of this is that we can go back 700,000 years back in time, and we can see the carbon dioxide concentration in the ice, the red line, and we can see the temperature, which is from deuterium-hydrogen ratio. Again, very clever chemistry, which I don't fully understand or could explain, but they can actually show these. And there's a regular oscillation. Now, some people say, well, the Earth has been far warmer than it is at present. It's just part of nature. But we can see that over 700,000 years, that it's gone up to here, and in fact it's gone beyond 390, it's up beyond 400 now, parts per million. And we can see the glacial times and the interglacial times. And I think even Donald Trump would appreciate what's happening here, if he cared to look at it. And if we look at the explanation of this, this is due to the fact that the Earth's orbit does change slightly over thousands of years. So the eccentricity here changes, and we see that the precession changes there, and the tilt also changes. So we've got periods here that are combined of 40,000 years, 100,000 years, and gives rise to interglacials of about 10,000 years. So this is why there is a variation in the temperature, the Milankovitch cycles. A Russian that worked this out, I think probably about 50 years ago, why we do get the ice ages. And in fact, we're probably due to go into an ice age fairly soon. And in about the 1970s, people were getting worried that we might be heading for it. But I think the fact that we're putting so much carbon dioxide into the atmosphere has put pay to the next ice age for quite some time. So those are the important things, and when we put this into the models, we can see that there's a range of temperatures which go almost up to 6 degrees here and about 1 degree there. So we've got different scenarios. So when people criticise scientists about their climate change projections, they say, oh, it's not going to rise by 6 degrees C. There's a range. There are different scenarios because we don't know fully what's going to happen. It is actually from the models, the mathematical models, that they are producing. And people say, well, you know, they're just models. You put rubbish into a computer, you get rubbish out, which is perfectly true. But we can see that if we go through, here are 58 simulations from 14 different climate models. Now, different academics have developed their own models. We in this country use the Hadley model from the Hadley Centre of the Met Office. And this was set up a number of years ago. And I think it was when Margaret Thatcher spoke to the chief meteorologist. And she, being a chemist, she might be a controversial politician, but being a chemist, she was actually quiet for half an hour while he spoke, because she understood what he was saying and realised what he was saying was perfectly true. And so the Hadley Centre was set up, and it's doing a lot of good work down in Exeter. And they are looking at these projections. But there are other countries that have their own models. And the thing is that how does the model actually predict what happened in the past, just before it gets to the future? And we can see that indeed there are quite a lot of variation there, but if we plot the average of these 58 simulations using 14 different climate models, we see that there's an average red line there, and it's not too far off the black line there. And the yellow means the variation there is between all of these. Now, weather is what happens from day to day, and climate, we generally like to see periods of 30 years, and we like to see trends with groups of 30 years of data. But the weather, we can say, is reasonably random, but the climate, we can see here, is not. It's chaotic, but it's not truly random. If it was random, it would be around 0. This is what we call a temperature anomaly. And all it means is the difference between the temperature now and what it was historically. So you take a historic average to work out the anomaly. So it's the temperature increase, effectively. And we can see that weather is a chaotic process, but chaos has a trend here. And we can see that trend is going upwards. And this is why we have a band of figures depending on the scenario. And the meteorology is basically differential equations which have been known for many years, and it's just how good a computer you've got to solve those differential equations from smaller and smaller areas of the Earth. So you can carry on for years after years refining your models depending on the power of your computer. And one of the most powerful computers we've got in the UK is in Exeter. And you go into the room where this supercomputer is, and you just hear a faint hum. And there's only about 1 or 2 people in the room. But this is doing wonderful predictions. It's also the same computer that's working out the daily forecasts. And for good or bad, we all know days when, I thought it was going to rain today and it was a beautiful day. But the weather forecasts are getting better and better, and actually for locations as well. So we're improving all the time. And this is generally that trend, and that chaotic trend which is rising. So I think that the model that depends on the mathematics and solving of the differential equations is pretty sound. But when we have a future, we've got to say, well, what's the population going to be? Because as the population increases, if we all use about the same amount of energy, then the energy is going to rise up in proportion to the number of people there are. In my particular area, we're making things more and more efficient, and, for instance, a lot of people now like air conditioning. And a lot of people in Africa will want air conditioning. The population increases, and the number of air conditioning units can actually swamp the energy savings you hope to make. We're getting more and more efficient light fittings and lamps, light-emitting diodes. But the thing is that as the population increases, there will be more and more uses of them. And I think that you have to therefore have a prediction of what the population is going to be. And we can see that there are 4 scenarios for how the population is going to vary. The worst is going to be about 12 billion there, or it could even, those are the error bands. So we've got to use that as well. And again, the United Nations have groups working on this to predict what the population is going to be, because we have to plan food and things like that. And I think David Attenborough has recently raised the problem that our population is increasing. One of my best PhD students is now the Minister of Energy in Burkina Faso, one of the poorest countries in Africa. And when he was doing his PhD, we were looking at the energy consumption. But by 2030, their population would have doubled, because medicine is now so good that people don't die in childbirth, and they keep old folks like me alive. So you've got that problem that the population in areas outside Europe is going to increase enormously. Also, some people say, well, who cares about what happens today, because we've got a generally rising economy and the gross domestic product will go up, which means effectively these people will be wealthier than us. They will be able to afford to do all these things. They'll be able to afford solar panels and wind turbines. Who cares? Well, the thing is that is true, but we should care, because there are certain things that money cannot buy. And if we have irreversible things, and I suppose a slightly trivial example would be if polar bears become extinct, although I suppose to biologists and that's a very serious matter. But however much money you've got, you might not be able to bring them back at all. And it's that worry about we go beyond the tipping point of the earth that we become into a situation where we cannot do anything about it. And people are therefore worried about 2 degrees C, and it's now being ratcheted down to 1.5. So these models are also in there, and I think the most robust part of that model is actually the weather part. And again, we can see that we've got this variation. So it's not one figure, there's a variation. And when people come to, for instance, just design a building is around for 50 years. So what's that building going to be producing in greenhouse gas emissions in, say, 50 years' time? You have to look at the data, choose the scenario you want to use, and do a number of runs on the computer model to see what it's going to produce. And that's quite a difficult task itself. Most people tend to use the middle scenarios, so that in the middle there and around in the middle there. But the other interesting thing is that I mentioned this 2 degrees C rise. Paul Eakins, who's actually a control engineer who's become an economist, which means I understand what he's talking about. So he's quite an interesting character. And his student McGlade actually said, right, if we're going to achieve that 2 degrees C and stay within the 2 degrees C rise above pre-industrial times, when there wasn't too much, the carbon dioxide was fairly level, what have we got to do? And notice there's a 50% probability. There's a lot of probabilities with these scenarios. And they worked out that we have to actually leave 2/3 of the fossil fuel in the ground. So it means that we've got to leave 82% of our coal in the ground, 49% of the gas, and 33% of the oil in the ground, if we're going to achieve 2 degrees C. Bearing in mind that governments and the IPCC now are saying it should be 1.5. Now, these are drastic changes and great changes in lifestyle, which are going to be very, very difficult to achieve. Because to a certain extent, we're wedded to our car, we like air conditioning and things like that. But I think the first thing is, how do we get rid of using so much coal? And if I mention this fellow again, Donald Trump, he wants to revive the coal industry in America. They don't need the coal in America, as I'll explain later on, but we want to stop so much coal being used. And we can see that generally the energy consumption of the world is rising up and up. So it's going to be very difficult to keep the carbon emissions down. And going back to if we have to leave 2/3 of the fossil fuel in the ground, some people say, well, we're running out of fossil fuel anyway. Unfortunately, we are not. This is looking at 2050. And this is BP's technology output, and it's reported in the Times. BP and Shell give quite a lot of information out. Now, the demand for fossil fuels in 2050 is 2.5 trillion barrels of oil equivalent. Always the oil companies talk about barrels of oil equivalent rather than kilowatt hours. And the thing is that if you look at how much can actually be recovered with today's technology, it goes all the way around here, which is almost double the amount that we will need in 2050. And if you then look at new discoveries and new improved recovery like fracking, we've got 3 times as much fossil fuels as we will need in 2050. So there's no worry about us running out of fuel. We've got 3 times as much as we need in 2050. So this is all rather worrying. And the Intergovernmental Panel on Climate Change, which is part of the United Nations, has as its president this man here, Professor Lee Ho-sung. And I'd just like to talk about the IPCC because this is what a lot of the information, this is what a lot of the governments take into account. And it looks at the technical and socio-economic information on risk of human-induced climate change, its potential impacts, options for adaptation and mitigation. It is not to do its own research or monitor climate data. It's assessment on peer-reviewed literature. Now, peer-reviewed literature is one of the great achievements of academic life. It's not somebody's opinion that you will read in a paper, like the Times or the Telegraph or the Sun. If an academic has an idea, they write a paper, an academic paper, and submit it to a journal. And there, other academics are invited to review this paper anonymously. And academics don't really get on. Because if you haven't got a wonderful discovery yourself, you might feel quite happy that you stopped a colleague's wonderful discovery because it said, no, it's not correct. And you can say anything you like there because it's anonymous. And this is what science is about. It's about disputation and arguing about things. There's no stitch-up between climate change academics. They're all after that money themselves. I mean, Margaret, my dear fiancée here, Margaret Carter, we actually worked in the same academic department. Yet Margaret was in a different research team from mine. And it's taken Margaret a few years to get used to the fact that perhaps I'm not too bad after all. I think that peer-reviewed literature, and this was shown in that I was actually looking at some papers and some work, and I saw this fellow had been a professor at Harvard, and I thought that sounds quite good, and it was looking at genetics and behavioural science, and he come up with some conclusion about morals, and I thought that'd be quite good for a sermon. So I got his book and I went through it. And then I saw on Wikipedia that somebody doubted some of his results from some of his experiments. And in America, they've got an institution which deals with things like this. And to cut a long story short, he's been asked to leave Harvard, and he hasn't gone back there because that data was fiddled. There was some time ago a Japanese researcher in genetics and was getting some very interesting results. So interesting that other people wanted to reproduce them and they couldn't. He committed suicide. So this, when there's a contentious issue, peer review is a good way of arguing about things and coming up with possibly how you can approach the truth, whatever the truth is sometimes. And I think that this has to be a cornerstone, that there are people that will write about climate change who don't have even a GCSE in science. Paul Nurse, who was president of the Royal Society, got very worried about this, and he actually interviewed a fellow called, I think it was James Dalrymple, that writes, I think it might be for the Telegraph, and he said to him, what are your qualifications in science? And he said, well, I haven't got any. He said, but I've got an opinion. So we have to say, what is the worth of somebody's opinion without the basic science and the data behind it? And this is the problem. So we've got to look at the scientific method, and I'll say a little bit about that later on as well. So the IPCC produces these reports. Okay, it does make a mistake from time to time, and it's jumped on. Poor Phil Jones at the University of East Anglia had his emails hacked. And Phil Jones did say some injudicious things and didn't want certain people's work published in the IPCC report. But he didn't deserve the pillorying he got. And I say that as somebody that worked with Phil Jones on 3 research proposals. And I would actually like to say I don't wish to work with him on another research proposal. But this is academic life. But he's not a bad academic. And so they produce these reports which are approved by the governments of the world because they all have this process of you write a draft and then it goes out to the governments and they can comment on them. And each comment comes back and they will talk about your draft, which has got page numbers and line numbers. And somebody might say on page 73, line 2, you say this, but this is not the correct reference, or we don't agree with this, or we think this reference contradicts this. And that is always very useful. And when I was on the IPCC, and I was only a junior player with a number of other people, but it was wonderful that the IPCC was recognised in 2007 with the Nobel Prize. But you had to go through and you had to give an answer to that. And you couldn't say this is rubbish. You had to say why you didn't agree with it or why you agreed with it and thank them. And then you prepare another draft. And that would go out for expert review. So that the world governments and their experts would come to a conclusion. The politicians never read the huge reports because each book, and it's about 4 books in an assessment report, and they're each about 1,000 pages long with thousands of references. I've never read the whole lot myself. My chapter with my 10 colleagues was enough for me. But there are summaries for politicians, so they can have the condensed version, and their advisors can tell them what's happening. And all these IPCC reports have been through this process, and the majority of governments throughout the world, including the American government, have approved it. Their scientists have said, yes, this is correct. So this is the world opinion. And yes, there are still arguments going on in science. We don't know everything by any means. The wonder of science is we don't know all the answers, we never will. And that's the beauty, there's plenty of work still to be done. But now, my particular area, I'd just like to say a little bit about the built environment. The surprising thing is that when we did our report in 2007, the buildings have a great potential to save greenhouse gas emissions. About a third of all greenhouse gas emissions come from our own homes and our own offices and buildings, including this chapel. But this chapel seems to be very good. I say that as I often come here. With its electric heating, they just seem to switch it on before the service, and it seems to be warm enough. It must be the buildings either side that are doing it, and it must be fairly well constructed. But it's quite basic things, that good insulation. In this country, we don't need to have heating or air conditioning. We should be able to design buildings where we need very little, and that you could have a type of passive house where if you feel a bit cold, you just do a few press-ups, get yourself warmed up, and you feel a bit warmer. I'm not that bad, really, but it's possible if we spend the money, and it's possibly only 10% more on our buildings, we could have them so much better. And also if we commission them so we understood the controls, that would be so much better. But we always want the cheapest first, and we're always disappointed that when we buy the cheapest thing, it doesn't always work as we expect it to. So the greatest potential for is actually in buildings. And if we quickly go through, we can see that buildings, residential buildings, it's second out of 15. I'll try and whistle through these fairly quickly. We've then got road transport, deforestation, and then we've got commercial buildings. So there's a great deal of potential. And some of that can be fairly straightforward, like making sure we've got plenty of loft insulation, that we've got double glazing, we switch our lights off, and things like that. So we can actually try and save energy. One of the greatest savings we've made recently, that the electricity has actually reduced in this country, is the fact that we've got LED lighting. And a tungsten lamp is about 10 lumens or 10 units of lighting per watt. 10 lumens per watt, whereas an LED is 100 lumens per watt. So it's 10 times more efficient. And its science and engineering is improving, but it's slowly improving. And the only result is that people think LEDs are so cheap now that they have them illuminating the outside of their houses. That's a rebound effect, that you think you've saved some energy, and then people will say, great, I can have more lighting, and I don't have to bother about switching it off now. Or I've saved so much money, I'll have another flight to a holiday somewhere. So it's almost sod's law, you can't win. And a recent interest of mine has actually been the urban heat island. And the urban heat island simply means that in areas like Shrewsbury, at night time, it's slightly warmer here than it is in the countryside. When I was working in London, I used to stand on the platform at Wandsworth Station waiting for the train. And at dusk, you'd often see starlings in beautiful flocks flying around, heading for Trafalgar Square, because they spend the night in Trafalgar Square because it's nice and warm. And then they'd come out to the countryside and get the worms and do their business, and then they'd roost back in Trafalgar Square. This is because the urban heat island is generally warmer in the urban areas and the towns, and this is showing the day and night time for the town. But when we do our measurements, we often have weather stations that are well out in the countryside. But the countryside, we can get very good temperature measurements and wind measurements, but at the end of the day, 66% of the world population in urban areas by 2050. We are all heading towards the cities. And this is the problem especially in China, where they've got great poverty in the rural areas. And for that government in China to make sure they don't have an insurrection. They've got to make sure that they keep the peasant population having a better quality of life. And a lot of them will be moving to cities. And you'll find cities there with 10, 20 million people. I think Chongqing, which I was at a few years ago, is about 20 million, and Shanghai is probably about 30 or 40 million. Incredible. I mean, when we think of our emissions in this country, they're dwarfed by what happens in China. And also it's worth pointing out that we're very proud of the fact that our carbon emissions tend to be going down. Well, I don't think we can be so smug because we're buying the stuff from China and it's their emissions that are going up to produce goods for us. And we should actually have a tax on carbon of the imports we have so we can pay for the emissions in China. So everybody's going to be heading for the cities. And one area they're heading for, rightly, is Manchester. In fact, if you go around Manchester now, it's got these tower cranes everywhere. It's going to be full of wonderful flats and that, and it's great because the flats where I live are going down in price and the houses are going down in price because everybody's going to Manchester. It really is a live place. They've got a lot of students there. But this is Greater Manchester, and the red there is Manchester City. And what we've done is simply put radiation shields with a little sensor in there, which is about the size of a pound coin, and this monitors the temperatures every hour, and we go around and download it, and that's a radiation shield, so you don't get the temperature that's affected by the sun. You want to know what the air temperature is, and if the sun shines on your sensor, it puts a very high temperature there, which is false. And we put these round Manchester on lampposts like that. And I joke that my colleague from our maths department and myself now download the data because we've run out of PhD students as we're retired or semi-retired. And we know the lampposts in Greater Manchester better than any dog around. And we put them around Manchester in circles so we can see how the urban heat island spreads out. And one of our Chinese PhD students did this, and he loved Kentucky Fried Chicken. And every time we go out, we see that there's a sensor near a Kentucky Fried Chicken shop. And Henry, we told him, he's now working in Nigeria, we said, you'll be really pleased, Henry, that they've opened 2 new Kentucky Fried Chicken shops and they're near your sensors, so I think you must have shares in Kentucky Fried Chicken. And then we take that data and we see that the urban heat island is mainly at night time, and this is what we call the urban heat island intensity, and it simply means it's the temperature between the urban area and the rural area. So if it's positive, it means that the urban area is warmer. If it's negative, it means it's colder. And generally, the effect is greatest at night, and that's the winter time. It's that tail there and this tail here in summer. So it simply means that you could have a hot summer's day in an urban area and it doesn't cool down and you can't sleep so well because the building hasn't got rid of its heat overnight as it normally would. I realise that this is probably getting a bit scientific and esoteric, so I'll go on fairly quickly. Looking at renewables and new technology, just to talk about things, I mean, we showed that solar radiation coming into the Earth is quite considerable, and here in Germany they've got some solar panels, and we've also got a number of solar panels in this country, although the feed-in tariff has been reduced to virtually 0 now. But these are the things that a lot of these solar panels are made in China, and they've got a far greater efficiency than photosynthesis. So it's no surprise that a number of farmers have put them in their fields because they can probably get more money that way than they can growing crops or having animals there. And you can actually have near zero energy buildings, and I was involved with Daikin, an air conditioning manufacturer, and also they produce heat pumps. And they had a heat pump in his office here, which is in Ruhr in Germany, and it's actually has solar panels here, and it's got geothermal heat pump. And this is to try and reduce the amount of energy it needs. And with the solar power, if you look at it over the whole year, you find it actually produces more solar power than it actually uses. So it produces more electricity than it uses. It's an all-electric building, and it's slightly positive 977 kilowatt hours over this period. So it is possible. In this country, I think we're getting more low-energy housing, and they sometimes call them passive houses. That's when we look at the energy required. If we look at the Sahara, and there's not a lot going on in the Sahara, if we put photo cells of this size in the Sahara, we would produce enough electricity for the world. Oh, please switch it off. We've got to save energy, haven't we? I hope it's on the low-cost weekend tariff mark. And if we look at this little square here, that would do for Europe. And this is from a German researcher. That would be Germany there. So in actual fact, there's a technology there, but of course there's the cost involved. But then, if we look at, we could have a supergrid where you can actually have electricity transported across the Mediterranean, so that a lot of the solar here could go across and help what's happening in Europe, or go south, so that Africa could be self-dependent on solar power, solar thermal or photovoltaics. And there's also wind that could be connected up, and also geothermal and biomass. Notice how many of those wind diamonds are around Britain. We've got one of the best countries for wind energy. And also in the States they're talking about having a supergrid. And their electricity system is pretty chaotic. They've got different systems at different voltages and frequencies, and they've got to do something to actually perhaps get some of the wind energy here over to the east coast and over to the west coast. And if the solar here, that can go north and it can go east. And it would use high temperature superconducting cables. And the refrigeration loss is estimated to be half the resisted losses. I've got these slides in because I did have to give a talk at a superconducting conference. And here is actually the type of superconductor cable that we're talking about. And it could actually have a DC supergrid, and it would reduce pollution. And also it had hydrogen, because a lot of people are thinking hydrogen is the fuel of the future, because you can get your wind turbines just simply generating hydrogen, and you then use this as a fuel. And you could also use it to be cooled down, so it's a cryogenic material to keep the superconducting cables very low temperature, because superconductors have to be kept very, very cold. So you'd use things like liquid hydrogen or liquid helium to keep them very cool, because the resistance then decreases substantially. And they're very good for long distance travel for electricity, transporting electricity. But again, it's a cost. And I think at the end of the day, if we're going to actually achieve carbon savings and reduce greenhouse gases, it's going to be at some expense. And here's the superconducting cable itself. And this has actually been installed in Germany, and it's actually been running since 2014. And you could, for instance, take this into the centre of a town, and they are financing this simply for the fact that as it's DC and they've got different ways of using DC, it doesn't use large transformer sites. So just the cost of land in the city centre of having a smaller substation saves the cost for having this superconductor. But it is something slightly experimental. But then we talk about trying to save energy and unexpected consequences. And here they are, these two dinosaurs saying we're at the top of the food chain and rulers have always surveyed. What could possibly go wrong? And here's this meteor that's just about to land near Mexico, which they think did for the dinosaurs. Unexpected consequences. The tragedy at Grenfell Tower, where insulation was put on the outside to try and make this tower block much more energy efficient. Similar things were being done in Salford. And I looked at these Salford blocks and I saw this going on and I thought, yeah, that's really transforming. It's doing a lot of good. I used to work as an energy manager in Wandsworth, and our tower blocks were quite a problem for us. And I think they've now been sold off, and they're very expensive flats with good heating and with good security. And that was one of the problems, security of some of these flats when they are in local authority control. But the thing is that this was done with good intentions. £10 million was spent on putting insulation on this. The only thing is that quite a few of the firms were penny pinching and did silly things. And some of the people that were selling the insulation were lying about the properties of the insulation material. Also, the fire regulations hadn't been upgraded. The government said that if you change the regulations are bad for industry and capitalists. They don't like too much regulation. And therefore, if you amend your fire regulations, if you put one new clause in, you've got to take 3 others out. So how you can do something like that is just a simplistic thing that politicians come up with, which is crazy. But our fire regulations are very difficult to understand, and it's quite a complicated issue. And I think the Grenfell Tower inquiry will carry on for some time. And I immediately thought that with a building like this being concrete, it would be fairly fireproof. And if you've got doors that are fairly fireproof, you can fairly happily stay within your apartment or your flat for about half an hour, knowing that the fire brigade should be able to get to you. But what had happened was that they put in new windows, a new PVC, and they happened to be rather flammable. So when anything happened, the UPVC would catch fire, and catch fire fairly quickly. And they'd also got in there fridges and freezers. And it seems, I don't know fully what happened, but the freezer and the fridge actually work by pushing heat out to keep the inside cool. And if you put it up against the wall, you've got a fair amount of heat coming out. And it's quite probable that the insulation on that fridge would catch fire, or the cabling going to it. And there have been a number of fires like that before. And there was one in Manchester, but they managed to put it out fairly quickly. But this just so happened to be quite close in the kitchen to the window. And so the fire went from there across to there. And then it got onto the cladding, and the cladding had some material in it, and that then caught fire, and horrible consequences. And this is, you can't actually realise some of the unexpected consequences that do happen. It's also when we design buildings that we've got passive buildings going up now. basically passive house because it originated in Germany, although there are plenty of low energy British buildings. And to use as much solar as possible and have very little heating. It would probably go down to a minimal amount, and we can see there it would probably annual heat requirement about 15 kilowatt hours per metre squared per year. That is pretty small. So a passive house is one of the best insulated houses you could have. And you want to make use of the solar, the heating from the sun. So they designed 2 passive houses in South Wales and put them up. And notice that this house here, the large house, has got big south-facing windows. And this one's got small south-facing windows. So this will get a lot more solar radiation than this one. So you think, jolly good, keep me nice and warm in the winter, which to a certain extent it will. But notice this has also got some blinds, because when it comes to the summer, you've got to remember that you can get overheating. And we've solved the problem of keeping our houses and flats warm enough in the winter, but we've yet to realise what happens in the summer. And the result is that we put in these low energy buildings, and we got another problem. People are saying, well, it's wonderful in the winter, but by God, it doesn't get hot in the summer, because solar radiation is quite intense, and you only have to lie on the beach to appreciate how warm it can be. And the building with the big windows here is the red. Now there's comfort temperature, and this is the difference in temperature between comfort and discomfort. And the big windows there, it's getting quite hot during the summer, and this black one is the one with the smaller windows, it's less hot. Was the building with large windows badly designed? No, it wasn't. The people were told that they should put the blinds down when the sun comes out to stop it getting too hot. But they didn't wish to, they liked the view. So they've got to understand the controls and the consequences. So they were misusing the controls and the shutters. But when you think about it, if it is a nice sunny day, would you want to bring the blinds down or draw the curtains? It is an unusual thing. So again, this is a slightly unexpected consequence. I realise that I'm probably going on a bit, so I'll try and speed up a bit. But with climate change, you've got climate deniers, and here's the prime one. Donald Trump thinks the concept of global warming was created for the Chinese in order to make the US manufacturing non-competitive. Now there is a grain of truth in that, in the sense that the Chinese were exporting a lot to the US, and if you can make one country have higher taxes on its carbon, then its products will be more expensive. But I think that the fact that it was created by the Chinese are very clever, but I don't think they quite did that. And the sad thing is that in America, the energy is actually going down, and the carbon intensity of electricity is actually reducing. And it's reducing because they're not using so much coal. They're actually getting gas from fracking. And they're using a large amount of gas, and it's made a tremendous difference. America will soon be self-sufficient in energy. But the trouble is, they've got all this coal. What are they going to do? They want to export it and send it around the world. And as we know from Paul Eakin's graph, we should be leaving it in the ground. And I think that Trump wants to expand the coal industry as if people desperately want to go and work underground in a coal mine. But just to show you the types of things that can happen, this was actually a slide that was used by an American academic, Reinhard Rademacher, when we gave a talk together. And this is part of the Massey Valley in, I think, on the east coast of America, and they discover coal. And the interesting thing is there's a little red circle there, and there's a little farmhouse down there in this wonderful green area. And they found that there was coal there. So they don't send miners down holes to pick it out, they blast it out, and they just take the mountain top off, and it's just excavated out with excavators. So it's very much the surface. And that's what resulted. And that's where the farmhouse was, where that red circle is there. And when they dug that coal out, it cost $10 a tonne, and by the time they got it to the power station, it was $40 a tonne. Economics is just so cheap. And they probably didn't have many people working there, so Trump wanting to get the whole of America employed, or a large number of people employed, this type of coal mining doesn't actually employ very many people at all. It's very cheap, but we have to go away from coal because it produces twice as much carbon dioxide as gas. And Macron, who's got his own problems at the moment, actually stood up in the Senate and said there is no planet B. Originally he and Trump got on, but he's actually spoken truth to that guy. And Macron himself has got problems because there are the yellow vests, and they are against him raising the price of petrol. And we've had similar problems in this country when we've tried to raise petrol and diesel prices. People will protest about it. But it's got to be done effectively so that we can actually reduce the amount of energy that we use. Energy is far too cheap, far too cheap. But there are also other people from America that do not agree with Trump. America's doing wonderful things on saving energy. The person leading my group on the IPCC came from California, from the Lawrence Berkeley Laboratory. And they're doing wonderful work in California. And most of the states in America are actually in favour of reducing energy, going green and so forth, especially in California. And here we've got Michael Blomberg and Jerry Brown forming that team that went to the delegation where they discussed climate change. We call it a COP, Conference of Parties, which simply means when all the countries get together to decide what they're going to do about climate change. And to actually say they are keen to prove that there are many US voices against Trump's anti-climate policies. And I think some of Trump's own family believe in climate change. But Xi Jinping does believe in climate change, and they're doing a lot of good things in China to reduce the amount of pollution and energy consumption. And Xi Jinping has vowed to protect the landmark Paris Agreement, which aims to curb climate change. He is stepping into the world position that has been vacated by the Americans as they go more and more isolationist, which itself is quite worrying. From an energy point of view, though, they're producing a lot of power from wind, far more than the United States, and there's the United Kingdom down there. We're a much smaller country, but that's what China is actually doing because they know that pollution and climate change is a serious problem. And they want to increase the prosperity of their population. And there they are with solar power. Most of the solar panels we use in this country are manufactured in China. China's got some excellent engineers and scientists. And they're also the biggest investor in renewable energy. And they are also the biggest helpers for developing countries. And that is a good sign and a bad sign. It means that most countries in Africa have been bought up by China. China is becoming a very powerful country. Now, I don't want to go too much into politics, but I was in China recently, and Xi Jinping is there for life. They love big data. They are monitoring everybody in China, as to what they do on a quite minute scale. The Chinese Communist Party is a very small minority of the population, but they have a lot of power. And you know the Communist Party members when you meet these people. So it's a very worrying situation that China are the new colonial power. And I think that my student, who was the energy minister in Burkina Faso cut off all links with Taiwan, and when he left me for a meeting in England, he said, we're now going to Beijing to talk to the Chinese. And the Chinese are interested in Burkina Faso because they got some gold there. The Chinese are only interested in some of the property they've got, or some of the resources that are there. And they propped up Mugabe and paid for millions of pounds so his office could have marble walls for his office. They also are very keen on getting in contact with the Saudi Arabians since there's been the trouble over Khashoggi. And I think that politically one's got to be very careful of what they're up to. And then we come to the thing, why deny? There's an economic reason. Carbon reduction comes with a cost. And we should actually accept that. And the carbon reduction can mean a change in lifestyle. People often do what they do today and what they do tomorrow, what they did today. And it comes with a cost. Oh, sorry, I think I'm right. I should put my glasses on. And also fossil fuel companies. But then there's Professor Daniel Kahan at Harvard, and he talks about cultural cognition and how individuals form their beliefs. And he says that what people believe about global warming doesn't reflect what they know. It expresses who they are. So it's a tribal effect. You can often see this in some religious societies. They believe the most fantastical things. But the more that the world says that's nonsense, the more they have a spirit of getting together, they are the people that know the right answers, and that they expect to be persecuted and ridiculed. And Kahan has done work looking at people's political affiliations. And just to say, if we look, is global warming evidence solid? The Democrats there are between 90 and 88%, whereas Republicans are down here. So you can't necessarily say that Democrats are more intelligent than Republicans, but we are all selective in the facts we look at. And quite a few of us aren't as objective as we should be, and I include myself there. But I think there's also anti-science. There was once an eminent chemist gave a talk in Manchester, and somebody came up to her and said, "You're a chemist. You're responsible for all this plastic in the Pacific Ocean. You're killing off all the animals with this plastic." And she said, "Well, plastic's quite a good material, but things can be used well, they can be used badly. And what do we do with the plastic afterwards?" And it's that type of thing. It can be used for good and for bad. It almost goes back to how we deal with it. And I think that there was also a person quite a few years ago that C.P. Snow. Now he was an author and he was also a scientist, so he straddled both. And I'm just about to... he came about with the science being the anti-science, and people being proud of the fact that they read most of the plays of Shakespeare but couldn't add two and two together. You know, that old phrase, "Oh, I'm no good at arithmetic." But if you said, "Oh, I've never read any Shakespeare," you're looked down on. This war on science, which also goes to evolution as well as climate change. And it's the age of disbelief. A third of Americans believe that humans have existed in their present form since time began. And the news media give attention to mavericks, naysayers, professional controversialists and table thumpers. So I thought, as it's the Darwin lecture, I better say it's not only climate change deniers, but evolution deniers as well. And here we've got a wonderful centre in Kentucky, I think, where they show Adam and Eve and a dinosaur. So, and the fact that everything started about 10,000 years ago, almost as it is today. And Karl Popper actually said that you should have the scientific method. And I must confess that when I was studying science at school, I did have difficulty with evolution. Simply to the fact that I'd do a physics experiment, I'd see an objective, and I could do an experiment and prove something to myself. It's very difficult to do an experiment with evolution. You can't take hold of somebody and see how they evolve. And all the things about missing link. And it's so difficult to get your mind around in millions of years. And the fact it's purely chance that things evolve. So Karl Popper actually says the typical experiments, and I think we've got to go beyond that. And actually say that observation and what Darwin did does lead on to excellent science, even though it doesn't necessarily comply with Karl Popper's dictum. And Stephen Jay Gould explains evolution, all organisms related by ties of genealogy or descent from a common ancestry. Lineages alter their form and diversity through time with descent with modification. It is not ultimate origins or ethical meanings. It should not be saddled with Western social prejudice. And it's not a concept of progress. And I think that's quite important because things change, but they don't necessarily progress. And this is saddled the evolution to a certain extent. And it came home to me that my late wife had to have chemotherapy. And her oncologist said, I'm sorry, but once you've had one chemotherapy, we have to change the chemotherapy because the tumour cells have adapted and got used to the chemotherapy. And I was talking to another doctor and they said it's almost evolution in front of you. It's those tumour cells that are fit enough to survive the first chemotherapy that they will then expand and will actually be not so amenable to being killed off by that chemotherapy. So you're almost seeing something happen in front of your eyes with the horrible instance of cancer. And they also do it with fruit flies there. And there are other experiments where this is done as well. And just before I get on to ethics, this fellow Robert Plomin is a psychologist and geneticist and looks at why we have certain traits and that they might have genetic origin. And he said that DNA is one of the most important factors in who we are. How DNA makes us who we are. And I won't go through all of that, but this can be a little controversial. Except to say that you've got to read what he's actually saying. It's about populations, it's not about individuals. Because you have certain DNA, it doesn't mean to say you're destined to do that or this. But the thing is, he uses science and he takes identical twins and fraternal twins and looks at correlations. And when I looked at his book, I thought, this is sound science. It's how you interpret it that can be. But there's also somebody, Oliver James, a highly educated, privileged person from Cambridge University, but he's a writer and journalist, and he's had a career as a broadcaster. And I think the fact that he's a journalist, he probably likes to be a controversialist as well. And he's mocked what Plomin has actually done. But Oliver James himself has been ridiculed by a psychologist at University of Edinburgh who said James wrote a book, Not in Your Genes. And he says it's a compendium of psychological myths and legends, and bending over backwards to avoid awkward conclusions. And he says that James is scientifically illiterate. And I think we've got to be aware of that there are some quite highly educated people that will put these books about and these ideas, but there's not a lot of science and that scientific method behind it. And that's the important thing, that Plomin has been criticised by Oliver James, that James says he believes that sticking with the genetic story holds out no hope. Instead, he prefers to stick with the environmental story, which is far richer narrative, full of parental missteps, social maltreatment, educational neglect. And I apologise, it's what Robert Plomin said about Oliver James. That there's a bit of a spat between them. And I think at the end of the day, it's the issue of where's the evidence? What's the scientific background to this? Now, Pinker, another American, has actually said the importance of science, new technology, and enlightenment now. That a lot of people think that a lot of the woes of this world are due to scientists and engineers. But Pinker actually uses statistics to argue that health, prosperity, safety, peace and happiness are on the rise worldwide due to values such as reason, science and humanism. And he simply shows extreme poverty. Most people think extreme poverty is getting worse. It's not. There's the graph, it's come down. This was a UN Millennium Goal to reduce world poverty, and it achieved its target 5 years early. So there is a lot that's been done that is in the background and we don't necessarily know about it. And there's life expectancy. We must admit that a lot of people around the world are living longer. Whether they're happier is another matter, but we are, to an extent, making things better. And just to finish off, we're in a Unitarian chapel, and I think one of the key things of Christianity, Judeo-Christian, and in fact most religions, that love thy neighbour as thyself. Love, I think, equals respect. There are many Greek words for love. But I think it's extended better if you think of Kant, that you act only according to that maxim where you can, at the same time, will that it should become a universal law. I mean, if you love somebody as thyself, I mean, I might say, right, I'll take my next door neighbour, and to show my love for him, I'll take him to a Charlton Athletic football match. And he might be a Shrewsbury supporter, or he might hate football. And if I take him to a football match, he might absolutely hate it. So you can't treat exactly people as yourself. But I think you've got to say, would it be a universal law which we could apply to everybody? And also that the Stern Review, which came out a few years ago, was criticised because an economist, a very famous economist, a very good economist, he was criticised because of his discount rate to look into the future. And now some economists are actually considering using ethical stances on interest rates for discounted calculations. Because most businessmen know if they don't want to do something, you just choose a suitable discount rate and you can dismiss that proposal and you'd end up doing very, very little. You can play around with discount rates quite happily to get the result you want. And now finally, people say, why should we bother in this country? We hardly have any population compared to world population. We're minuscule. We are. There we are, down the bottom there, and there's the world. Coming up to 12 billion perhaps in a few years' time. And then, correspondingly, our emissions are way, way below those of China, and below those of India, way below America, and there's the world carbon emissions. So what can we do in this country? We're such a small country, our emissions are so low. But if we look at it pro rata, what do we individually do? Our emissions are very much higher than they are in China, or in India or the rest of the world. We're still not as guzzling as the Americans, but there we are. So we are all neighbours in the world, we all share the atmosphere, rich and poor. Perhaps we should cap and converge, which means that we see how much carbon we can have in the atmosphere and divide it by the population. We would have to do a lot of reducing in this country. But can we actually look at the Chinese and say, right, you reduce your consumption. There's a lot of poverty in China. There's a lot of poverty in India. Are we going to say to them, right, you keep your populations at poverty level because we're quite happy with our life as it is? We've got to say that everybody should have the chance to have a decent life and to have the same carbon emissions. And we shouldn't be selfish. That there's no way we can negotiate with the Chinese and the Indians if we are doing absolutely nothing ourselves. So we have to do it, even though it makes a minimal amount to the world. So, finally, conclusions. The climate change is happening. There is a very strong evidence that man is influencing it via carbon dioxide. And we've got the urban heat island on top of that. And evolution is happening in genetic researchers as well, it seems. Many people are deniers and selective in their facts. Science and engineering are indeed making the world a better place. Many people, especially politicians and policymakers, do not understand science. How many people in the UK government have a degree in science? Very few, if any. We need to speak up for science and engineering and encourage young people to become scientists and engineers. And perhaps we might save the world. Thank you, and I apologise for going on far too long.
I'm sure some of you might have questions, and we've got a microphone if anybody wants to ask Jeff some questions. Please put your hand up.
Why do you think so few houses, or why houses, all the houses being built in Britain at the moment, are not automatically having solar panels fitted? And would it be a good idea if that was implemented?
Yeah, it would be a good idea. I think the thing is that sometimes Germany has got a lot of solar panels, and in the summer they have a problem with the electricity generator. They have to export it because the system can go unstable. Now, in life, there's no simple solution. And when it's not sunny, what are you going to do? You've got to have background generation. So you've got to think about what happens when you haven't got that. So what you've got to do is have a number of different solutions. So it could be wind, because wind often blows in the winter, and it's often worse at night than it is during the day. And you have the solar during the day, and especially during the summer. In this country, our peak electricity load is during the winter. It's not during the summer. But with air conditioning increasing, perhaps there will be more demand in the summer. And I think these things are there. That what is more important is that we should be ensuring that they carry on putting these things in China, because what we can do is try and contribute so that China does not have to use so much coal-fired electricity generation, that they use it a lot more. And we should be paying for the carbon they use in producing the goods we actually have, and for the solar panels. I mean, to be honest, putting solar panels into Manchester, where it's cloudy quite often, is not as good as getting something in the Sahara to supply Africa. So I'm not dismissing solar panels, they are good. And I think that a lot of people went into it, and the government were wrong to reduce the feed-in tariff, because there are a lot of companies now set up which have now gone bust because of government withdrawal of the feed-in tariffs. But they were also doing work abroad as well. And I think it's a mix of these renewables. But at the end of the day, buildings really should not need much heating if they're well insulated, and they shouldn't need much air conditioning either if they're well designed.
Jeff, regarding the renewables that we haven't talked about, is tidal. Tidal seems to be there morning, noon and night, and it doesn't get sun, wind, and renewable tidal energy seems to be one of the things that was considered a while ago in Swansea Bay, I think.
Yes.
One of the projects that was in line for some development, but it seems to have disappeared off the agenda. Do you know why that might be?
Yes, I've got a few colleagues at Manchester that look at wave power and tidal power. On the waves, we had the bobber in Manchester, the Manchester bobber. And basically it was a little float that went up and down with the waves. And there was a wire going up and it went round and it ran a dynamo effectively. Now that's a beautiful idea. The only thing is that there's so much power in the sea. I mean, 1 metre cubed of water weighs a tonne. And when you see those waves coming in, you're looking at a lot of power. And the thing is, it has to be so robustly constructed and anchored to the seabed that it becomes very, very expensive. So we've got one of the best areas in the world for wave power and also wind energy. But I think with the barrages and so forth, I mean, there's the Severn River as well, and I think that there are ecological issues with that and the wading birds and so forth. And again, it's a large amount of money, but yes, it could be done. I mean, in France, they've got a very good tidal system where they've got a very high tide. And I mean, well, it's the River Severn, isn't it? I mean, you might even get the Severn bore. You might even get some energy out in Shrewsbury. It is one of these things that the cost, and it's when it occurs in the background. So things that we should be investing in, but it means that your electricity bill will go up because of the investment in that. And a lot of people think of the first cost and say, my electricity bill's far too high anyway, I don't want any of these renewables paying for it.
Any more questions?
Thanks. In terms of what the UK should do to reduce its carbon emissions, what is it currently doing that it shouldn't do, and what should it be doing that it isn't currently doing?
I think that the government, for instance, did say a few years ago that 2016 we would be building zero carbon housing, and 2019 it would be zero carbon or near zero carbon commercial buildings. I think the building industry behind closed doors said to the government, you realise that the house prices and office blocks will go up so much in cost, we won't be able to afford it, we won't be able to sell houses and blocks, we'll have to lay off people, don't do it. And they listened to industry, and the result was it got forgotten. So also things like the fire regulations should have been addressed. And I think that is one of the key areas. But I mean, politicians to a certain extent are in a very difficult position, because I remember Tony Blair saying, I agree with all that you guys say about climate change. He said, but some of the things you propose, if I put them forward in our manifesto, we would not get elected. And that is a serious thing. It really comes down to you and me and how we are prepared to vote. And the fact that we've got to accept this is a very serious issue. It's going to cost us money. It's going to mean a change in lifestyle. And we've got to be humble enough to say, yeah, we've had it good, but we've got to accept these things. And the fact is, in France, they've had the riots over the petrol price hike, but also there are other things in France. But we also, the fuel cost escalator has not been implemented since Gordon Brown's time. And I think that there should be more encouragement for people to actually try and save, and we should perhaps have more transparency and as to how much, for instance, we do actually consume. And some electricity companies now say that, you know, comparable houses as yours are using this amount. You can see whether you're a good consumer or a bad consumer. That they should perhaps give a little more to kind of encouraging people to be aware of what the energy use they actually are using and what it does actually mean.
Well, thank you very much, Jeff. I'm sure it'll be available for people to ask questions on their way out. But thank you very much for coming, and I hope you found it enlightening, interesting, and perhaps affect your own energy consumption. Really. And thank you for coming to the church. Thank you.
So I think I better add on to this that was, yes, a Professor Geoffrey Levermore at the Unitarian Church in Shrewsbury. None of this was created by me, and this is purely Geoffrey's work. I just asked him permission if I can share his lecture, and he kindly agreed. So thank you, Geoffrey, for letting me share this. Thank you to everyone that organised it at the Unitarian Church in Shrewsbury, and I hope you enjoy the rest of the festival. And yeah, have a great day. Peace out, guys.